Good day, dear students. My name is Tlebaldinova. I'm a lecturer of computer modeling and information technologies. Today's our lesson is software and operating systems. These are learning objectives. List the different categories of computer software. Describe the purpose of system software. Explain the difference between a high-level and a low-level programming language. And describe the purpose of compilers. This slide shows main terms of our lecture. Program. Program is a set of sequential instructions that tells the computer what to do. Software, a collection of programs, data, and information. And programmer, the person who makes a program. This slide shows the scheme of computer software. Computer software consists from system software and application software. System software has following parts such as programming languages, compiler interpreters, and operating systems. And application software has such parts as general purpose and specialized. Software that is the computer uses that operates a computer system. Included with the computer, embedded software such as firmware or the BIOS. Installed or loaded later, operating system and driver. Programming languages allow programmers to create programs. It's a set of words, rules, and syntax. There are many programming languages which are designed to solve specific kinds of problems. For example, C, C#, Java, PHP, Python, etc. Levels of programming languages: machine language, assembly language, high-level language, and application language. Machine language, they are written in computer languages. For example, binary, octal, or hexadecimal. Changed on the computer architecture. Programmers rarely write machine language. They write programs to translate code into machine language. Both produce the same result. This slide demonstrates examples of machine language and basic language. Assembly language depends on using some of the mnemonic symbols like ADD, SUB, MUL, DIF, ELV. Easier than the machine language, depends on the computer architecture, needs an assembler to translate the instructions to machine code. This code is an assembler version of the machine code. In high-level language, use statements that users can understand. It can be used very easily to solve complex problems. They don't depend on the computer's architecture. And it needs translators to generate machine code. Code like this gets translated to machine code. It's a code, language code. Then code like this gets translated to machine code. Programming languages built into applications. For example, VB in Microsoft Office. Database language create files, forms, queries, records, without the writing of any programs. Examples of database languages: Oracle, Access, and SQL. Compilers and interpreters are programs that translate the source code into computer code. Human writes source code using our language, the high-level language. Compilers and interpreters turn the source code into machine language, low-level language, code that the computer processor uses. Differences between compilers and interpreters: an interpreter directly executes the instructions one line at a time in the source programming language. A compiler translates all the instructions into efficient machine code. Translate the entire source code into an executable or compiled file. Languages that use a compiler: C#, C++, and Java. Interpreters translate and execute one instruction at a time, slower than the compiled code, uses a program to interpret a single line of code. Interpreted language examples: scripting languages such as JavaScript and VBScript, web languages such as PHP and Perl. So, in summary, I'd like to say that computer software has two major subcategories: system software and application software. System software operates the hardware and allows the system to run. Programming languages allow programmers to write software. Higher-level languages are closer to how humans talk. Low-level languages are closer to how computer talks. Compilers and interpreters convert human instructions to machine languages. So, next part of our lesson is about system software. These are our learning objectives: define an operating system, state the primary functions of the operating systems, list the primary types of OSs, describe the function of each type of operating system, list the three main types of operating system families, and give an example of a brand in each operating system family. So, an operating system is a system software that acts as an interface between the user and the computer hardware and provides common services for computer programs. Users and application software talk to the OS, operating system. The OS talks to the hardware and other system software. The OS informs the users other changes. Important functions: memory management, processor management, and device management, and file management. These are important functions of operating systems. Memory management keeps tracks of primary memory. When multiple programs are running, the OS decides which process will get memory, when, and how much. And memory management allocates memory when a process makes a request. Deallocates the memory when a process no longer needs it or the process exits or terminates. Processor management keeps track of the processor or processes and the status of all processes. Allocates the processor to a process. Deallocates the processor when a process no longer needs it. Device management keeps track of all devices, decides which process gets the device when for how much time, allocates the device to a process, and deallocates devices. File management keeps track of information, location, uses, status, etc. on the storage device. Decides who gets the resources, allocates the resources, and deallocates the resources. Other important activities of operating systems are security, control over system performance, and job accounting. Error detecting aids and coordination between other software and users. Primary types of operating systems: single tasking and multitasking operating systems, single user and multi-user, multiprocessing, distributed, embedded, and real-time. A single tasking system can only run one program at a time. A multitasking system runs multiple programs at the same time. Most modern operating systems are multitasking, such as Windows, Android, Linux, Mac OS. Single user and multi-user operating system. A single user operating system only allows one user to use the interface at a time, and multi-user operating system shares the resources among all logged users. Here, a single process runs on two or more processes. All the processing and the management happens at the same time, called as parallel processing. Distributed operating system. This type of operating system distributes the processing power to many computers. Each computer processes data as part of larger network. Embedded in a chip on the device, performs specific functions for the device: terminal, copy machine, camera, washing machine, TV, and so on. Real-time operating system. Input and output operations are happening immediately without delay. Time-critical devices, medical devices, scientific experiments, industrial systems, transportation, control systems. Families of operating systems: Windows family, Macintosh, Unix-like. These pictures are examples of Unix-like systems. Unix, Solaris, Linux. Command line and GUI of Linux in these pictures. So, an operating system is system software that acts as an interface between the user and the computer hardware and provides common services for computer programs. An operating system performs the primary system functions of memory, processor, device, and file management. Types of operating systems: single tasking and multitasking, single user and multi-user, multiprocessing, distributed, embedding, and real-time. So, primary OS families are Windows, Macintosh, and Unix-like. Next part of our lecture: application software. Application software is software used by user. It has two categories: basic applications and specialized applications. In this table, you can see examples of basic application software, such as word processor, presentation, instant message, web browser, compression. Specialized applications focused on specific disciplines and occupations usually requires a high degree of skill. For example, graphics programs, audio and video editing softwares, programming platforms, and engineering tools. So, system software manages system functions and interfaces with the hardware. Application software is for the user. User interfaces, it has two types of, such as command line interface and graphical user interface.